Hi everyone, my name is Saksham Sharma, and today we are going to study CPU scheduling. So this is my short notes which I have created. It is of 4 page, in which I will write all the what we can say all the important things which are come from this chapter CPU scheduling. So let us revise with me. So in these notes, as we know, if when you look up on the PYQ, you get to know that in from CPU scheduling chapter, there is a numerical scheme based on the scheduling algorithms like FCFS, SJF, LGF, like all this. So in this video, I am not covering the numerical parts of these algorithm. I just only cover the theoretical parts which can become in the GATE CSE. Means the MSQ question and MCQ questions which can become from this chapter. I cover in this short notes. If you want to know what are the numericals come from this, as only one type of numerical is come on from this chapter, which we discuss in next video. So let's start. First of all, we discuss about what is process scheduling. So it is done by process manager that handles the removal of the running process from the CPU and the selection of another process based on a particular strategy. So as our chapter name is CPU scheduling. So what is this scheduling means? How CPU is scheduling anything? So like when we running this computer also, when I run this computer also, I open the Chrome. I also open OBS Studio for recording this session, and also multiple things are currently running in my computer, like PPT or PowerPoint, any other things, all the other things, etc. So how these things are uh, operating simultaneously. So this is all done by this CPU. So what CPUs does is CPUs context switching these processes, like they context switch like they process my this browser for some unit of times, then my PowerPoint some unit of time, then my video OBS Studio for some unit of time. So and this what with this is done is they are context switching these processes in order. I get I think that these processes are operated simultaneously, but it is not operate simultaneously. It is operate on sequential manner. So this is how CPU scheduling work. Like in this, what is done is there is a process manager which handle the removal of the CPU processes. Like my OBS is currently running, then it take out, remove the running process, and add the next process which are going to execute. Then they remove that process and put another process which are going to execute further. So this is the intro of this chapter, and let's start what are the things which is important. So category of scheduling. What is the category of scheduling? There are two categories of scheduling: preemptive and non-preemptive. So in preemptive scheduling, priority scheduling, long term job first, short term short remaining time first, uh, and round robin. And non-preemptive schedulings are these all. So so you have to know that what are the preemptive algorithms and what are the non-preemptive algorithm, because this help in your solving the numerical part. This is the most important point, that some in some questions they are not mentioned that this is a preemptive algorithm or non-preemptive algorithm. They just write the solve this numerical by using SGF. So it is not right like preemptive, non-preemptive. So you have to know that SGF is a non-preemptive algorithm. So you have to solve that numerical by a non-preemptive SGF. Okay, so you have to know which scheduling algorithms come in which category. Preemptive algorithms are those algorithms where preemptive scheduling, we can say preemptive schedulings are those schedulings which can be preempt. That means we can take out the processes running processes partially, that the process is run partially, then we remove that and add another process. So you can remember by this trick, like prior to scheduling, you can think that based on the priority the things are removing and adding. Okay, long remaining time job first, you can remember this by like the big name it is. From the big name, the length of the name is big, that means they can be preemptive. Okay, or the length of the name is short, like SJF is short, LJF is short. Like these are the non-preemptive algorithm. Okay, you can remember this, or you can make your own remember trick also. So I personally use this. So LRJF, I know the working of this algorithm. I just forget that this is preemptive or not. So I used to remember like this. So short remaining time first, these are the preemptive algorithm. Round robin, it's know that there's a time quantum is given and we have to context switch. So this is a discussion part. Non-preemptive algorithms are shortest job first, longest job first, first come first serve, highest response ratio next. So if you ask me what is the most important scheduling algorithm which come in gate CSE, it's the priority scheduling, and shortest job first, shortest remaining job first, and round robin. These are the important, which are most of the PYQ have come on based on this. Types of which is the least important. Least important is HRR. Okay, highest response ratio next. These are the least important. FCF, where you know FCFS, but this is also not key in gate CSE. And LRJ. Types of process schedulers. These are the things which these are the point which we are going to discuss, like long term scheduler, short term scheduler, and medium term scheduler. From this, there is the MSQ questions are asked. So types of schedulers, there are three types of schedulers: long term scheduler, short term scheduler, and dispatcher. Okay, I use these colors also. Okay, so first of all, we talk about long term scheduler. What is long term scheduler? It brings the new process to the ready state. So what a long-term scheduler does is it brings the new processes, as you see the uh, process state diagram. If you know the process state diagram, uh, so or if you don't know, you can search in a Google also. You get to know the diagram of this process state diagram, in which the processes which are come from the in ready state, these are come by the long-term scheduler. Okay, so I will also share the diagram also. So I will share the diagram is here. So this is the process cycle. So here the new ready, running, termination, wait block, and block suspended ID. This is not video meant for, like, I explain all these things. This is for the revision purpose also. So I only explain the thing which are written here. It brings the new process to the ready state. So what is the work of long-term scheduler? As you know, I have written here also, long-term scheduler. It brings the new process to the ready state. That means when you click on anything in the desktop, like you click on the OBS Studio, so OBS Studio come. So that means when you click on the OBS Studio, the long-term scheduler pick the OBS Studio and keep it in the ready state, and this is done in the very short period of time. So this is a work of long-term schedule. It bring the new process which are going to create it, not the process which are running, the process which are going to create it. So these are put by the long-term scheduler. We also call the long-term scheduler as a job scheduler. It brings the new process to the ready state. It control the degree of multi-programming. This is an important point. So it control the degree of multi-programming. That means, what is the meaning of degree of multi-programming? The number of processes present in a ready state at any point of time is called degree of multiple programming. That means if we assume that there is a 10 processes are present in the ready state, that means 10 processes are waiting for running. So 10 processes are in the ready state. That means the degree of multi-programming is 10. Okay, so how that means, how many numbers of processes are there in the ready state are called the degree of multi-programming. So long term scheduler are responsible for increasing the degree of multi-programming, uh, as it how much processes they can come in the or add in the ready state. So this is the work of long-term scheduler. You have to remember only two things: that it is responsible for taking a new process into the ready state, which are going to be run further. or it is control the degree of multiprogramming in the OS. Okay. In short-term scheduler, what we have to know, short-term scheduler is also known as a CPU scheduler also. Okay. So it is responsible for selecting one process from the ready state for scheduling it on the running state. So what done is short-term scheduler. Here I write a short-term scheduler. You can see that short-term. What is the role of short-term scheduler? It pick the one process from the ready state. It pick the one process from the ready state and put this process into the running state for execution. It is for selecting. It is responsible for. So it is responsible for selecting one process from the ready state to the schedule it in the running state. Okay. So what we have to note here, it only select the process to schedule it and does not load process on running. So what is the work of short-term scheduler is? What is the work of short-term scheduler is? It only select the process which are uh, going to execute, or we can say which are going to in the running state. It cannot able to pick the process and put in the running state. There's a big difference. Like short-term scheduler only select that this process is going to be execute next. So how this process is going from a ready state to a running state, this is done by a dispatcher. So here when all the scheduling algorithms are used, it ensure no starvation due to high burst time process. So here we come for nextly. Here we come nextly. From here we come nextly. First of all, we know the working of dispatcher. Okay, so we have to get to know the short-term scheduler is not responsible for putting the job from the ready state to a running state. It only select that this job is going to be, or this process is going to be execute next. The work which is picking the job from the ready state and put it in the running state is done by the dispatcher. So dispatcher, what is it responsible for? It is responsible for loading the process selected by the short-term scheduler on the CPU running to ready state. So this is responsible for loading the job. Context switch is done by the dispatcher only. Context switch is also done by the dispatcher. Context switch means putting pick the job from the running state to the ready state. We can see in the diagram. Put the process. What is the context switch meaning? Like pick the job from the running state to the ready state and pick the job from the ready state to the running state. This is called context switch. Context switch means changing the processes which are going to be processed next. Like here also the context switches come, like for some point of so for some nanoseconds the browser is running, then context switch, OBS is running, context switch, PPT is running, context switch, uh, like PowerPoint or anything else is running like this. So the dispatcher does the following. So this is important. The one PYQ is come from this. What is the work of this dispatcher? Uh, in a MSQ, context switch is done by the dispatcher. Switching to a user mode. So many people don't know that the processes which are switching, they are done in the which mode? The user mode. Jump to the proper location in the newly loaded program. This is also done by a dispatcher. That means the process which are going to be running nextly, the process is jumped to the proper location of that newly loaded program. So these are points you have to know. So short-term scheduler is also complete. So here the point is, here when all the scheduling algorithms are used, so this is a point where all the scheduling algorithms are used, like here using long-term scheduler, also short-term. These are not the algorithms which are used. Algorithms are these preemptive and non-preemptive algorithms. Here the all of the algorithms are used. That means here we use short-term scheduler use all these algorithm. All these algorithms are used here to get to know which job are scheduling next, which scheduler is going to schedule next. So that's why here that it here all the scheduling algorithms are used. It ensure no starvation due to the high burst time processes. So the work of short-term scheduler is that it ensure that no starvation is occur due to high burst time. That means that what is meaning of starvation? That the process is waiting infinity. like a deadlock situation. It is that the process is not going to execute uh, anyhow. So this is called the starvation. So short term responsibility of short term scheduler is, this is also come can become in a PYQ, that what is the work of short term scheduler? Yeah, which scheduler is responsible for to ensure that the no starvation is occurred? So this is done by the short term scheduler. Okay. Medium term scheduler, what is medium term scheduler? What is the work of this? So long term scheduler, short term scheduler, medium term schedulers come here, means that this part is done by the medium term scheduler. It is responsible for suspending and resuming the process. It is responsible for these parts, suspending or resuming. The suspending part, block suspended. There's a one PYQ also, that in which state the process is in main memory, and in which state the process comes in CPU, or we can sorry, CPU, not CPU, comes in secondary memory. So you have to know that in these three processes, ready state, running state, and wait, yeah, block or block state, in these three states the process is present in the main memory. In these three states, process is present in the main memory, and all these states, in all these states, the process is not present in the main memory, they're present in the secondary memory. Okay, like in suspended ready or blocked suspended, the here the process is present in the secondary memory. You have to know also this. Medium term scheduler, what is medium term scheduler? It is responsible for suspending and resuming the process. Medium term scheduler is responsible for suspending and resuming the process. What is the work of this block suspended ready? This is not video for this, that I explain all the things here, as it is a short part. It mainly does, you have to watch the long video for this. It mainly does swapping, moving processes from main memory to a disk and vice versa. I will tell you that it is responsible for swapping, like moving, swapping, not context switch. It is not here, not context is not context switch. It is for swapping the what processes from main memory to the disk. Okay, or vice versa, from disk to main memory also. It is helpful in maintaining a perfect balance between the input output bound and the CPU bound. So it is helping maintain the balance between the input output bound. Input output bound means the process which spend most of their time in the input output processes, and CPU bound is the process which spend most of their time in the CPU, that means the running state. These are the CPU bound. So note, long term scheduler can increase degree of multiprogramming. Medium term scheduler can, this is an important point. So what are the notes here is, long term scheduler increase the degree of multiprogramming. Okay, and medium term scheduler, what is work of this? Medium term scheduler can increase or decrease the degree of multiprogramming. Increase or decrease the degree of multiprogramming. And short term scheduler does not change the degree of multiprogramming. So this is an important point. You have to know that long term schedulers can increase the degree of multiprogramming, like most of the like it take the more processes in the ready state. Short term scheduler can medium term scheduler can increase or decrease the degree of multiprogramming. And short term, like it can switches the process in the suspended ready, like that. This is can increase or decrease. Short term scheduler is no have no choice to increase the degree of multiprogramming, as it can only work as context switch. Scheduling time, these are the things which I have write. There is no use of this, as this are also help in only numerical part. So if you want to listen, you can listen, but this is not this is a numerical part, and you have to know the terminologies, that what are the things which are what is the meaning of these terms only. Okay, this is no use. If you already know, you can skip this. So arrival time is the time at which the process arrive in the ready queue. Burst time is the amount of time a process run on a CPU. Waiting time is the wait time of a process wait is ready state. These are things which we discuss in a solving a numerical part. You just have to know the formula of this only. Throughput. Somehow you forget this uh, throughput formula. So you have to know the throughput formula. This is important. Scheduling length is not asked in any PYQ, but maybe in the next PYQ, what we can say. So you have to just remember the CPU throughput and how to calculate the CPU idle time, CPU execution time, like this. Okay, so you have to know these two formulas, and one also which I tell you, how much time the process is, how much time CPU idle time, what is the percentage of time CPU is idle. So this question we discuss in the when we solve the numerical part. So what is convoy effect? This can be asked. Convoy effect is if the CPU get the processes of the high burst time, but at the front end of the ready queue, then the process of the low burst time may get blocked, which means they may never get the CPU if the job in the execution has a very high burst time. Okay, for non-preemptive algorithm, no number of context switch is equal to number of processes minus 1. So only the definition is important, not this formula. What is convoy effect? Convoy effective if there is a one process which is having a long burst time is present in the front, and this processes which want the small burst time is present after that, then their waiting time got high, as they only want, like they only want 2 nanoseconds for execution, but in front of them there is 1,000 nanoseconds job is executing. So what is the benefit of this? As these can process firstly, as these can process can work firstly like 2 nanoseconds, these three process can work, and then after that this long big job can execute. This is the effective way. But what is convert effect? The big process is uh, executing as their number is first, and after that the small jobs are there, but it cannot be able to execute as there is a big burst time job is present further. So if the CPU get the process of the high burst time, this the high burst time is high execution time, high burst time at the front end of the ready queue, then the process of the low burst time may get logged, which means they may never get the CPU if the job with the execution has a very high burst time. You don't have to remember the formula, you have to just know the meaning of this context, convoy effect. You don't need to remember this formula, but it can present in the back of your mind, it's no problem. For non-preemptive algorithm, you have to keep in your mind that what are the non-preemptive algorithm. You don't have to go back, you have to just see what is the non-preemptive algorithm, the algorithm which cannot be preempted. So the algorithm which cannot be preemptive, that means they are must be short in length. Okay, there must be short in line. That means SJF, LF, L, LFG longest first job, LFJ, LFJ, LF, SFJ, shortest remaining. Shortest remaining job, longest remaining job, and FCFS, and highest response time first. These are the things which are non-preemptive. Shortest job first. Okay, I say shortest remaining job. Somehow I say, but I keep in my mind there's a these word also. The shortest job first, shortest job, longest job first, first come first serve, or highest response ratio next. Okay, so non-preemptive I got the number of context switch equal to number of processes minus one. As how this is, you can, if you solve the numerical, you can also understand by your own. What is the meaning of aging? It is used to prevent starvation of a process. So important is a what is aging. Uh, I have not seen this in a PYQ, but I write this as they are in notes. It is used to prevent starvation of a process, like it prevent from the process to going in a starvation, like infinite wait. It gradually increase the priority of a process that has been waiting for a long time, like if there is a process in a ready queue which is waiting for a long period of time, that it increase slowly to increase the priority of that process so that this process can be come in the execution phase. It increases the chance of getting the necessary resources for execution. This reduces the risk of starvation. Okay, so I know that I you have to just know the meaning of these words. What is the meaning of aging, convoy effect? On not that much of the important thing is come now. Okay, I, here I had already discussed three important things we have to know. If I just say you category of scheduling algorithm, what are the scheduling algorithms are preemptive, what are the non-preemptive, and these things, long-term scheduler, short-term scheduler, and medium-term scheduler. After that, I just uh, give you the important this one. Okay, these are the terminology which you have to know if you are a CSE person. Not that much important from the grade point of view. So now the things which are going to discuss is important, which come in a gate PYQ, is minimum average waiting time, waiting or turnaround time among non-preemptive algorithm. So here most of the answer is where they ask you for the minimum average waiting time, minimum turnaround time, like which want a minimum anything waiting time, turnaround time. The answer is only shortest remaining time first, or if it's talk about the non-preemptive, and it's a the shortest job first. Okay, these are the answers which you have to answer in the PYQ. Like minimum average waiting time, which algorithm give the minimum average waiting time or turnaround time? And if we talk about non-preemptive, then SGF. Okay, if we talk about minimum average waiting time among all algorithm, like both preemptive and non-preemptive, then it is SRTF, means shortest remaining time first, preemptive. Non-preemptive always, what are the algorithm which is always non-preemptive? FCF is always non-preemptive. SGF, LTF, highest response ratio first. Sorry, highest response ratio next. This is not that much of important. Non-preemptive priority. As you know, priority is of two types: preemptive priority and non-preemptive priority. It is can be listed in the question if come from the priority. Always preemptive, which algorithm is always preemptive? There is no algorithm which is always preemptive. SRTF behavior as SGF. So this is important point. So when SRTF behave as SGF, so there are the two conditions when SRTF is a preemptive algorithm and SGF is a non-preemptive algorithm. How preemptive SRTF behave as a non-preemptive SGF? So when all processes arrive together, so you have to think alone what are the meaning of these 2 points in your mind, then you get to know. It's no way that I can tell you. So you get those 2 points. You have to sit and think about what are the meaning of these 2 points. So when all processes arrive together, so think of a scenario when all processes arrive together. That means wo arrival time is 0000 of all processes. Then SRTF behave as a, and second condition also. Second condition must be also true when later arriving processes are not smaller than running process. Okay, when later arriving processes are not small than these are the two separate. They are not dependent on each other. First condition is true, then also this SRTF behaviors SGF. If second condition is true, then also this. Okay, not like both condition is not satisfy. If if both conditions are not compulsory to be satisfied. If any one of the condition is satisfied, then these SRTF behave as SGF. I correct myself here. Not both condition must be true. Any one of the condition is true, then SRTF behave as SGF. If both of the condition is true, then this SRTF also behave as SGF. But if any one of the condition is true, then SRTF behave as SGF. It's like all the process. First point where first we discuss when all processes arrive together. So think of a scenario when the all processes are arrive together. That means the arrival time of the processor is 0000. So that means SRTF see the burst time, minimum burst time. So minimum burst time execute first, then second, the third, then fourth. So there's no concept of preemptive and non-preemptive come here. They all execute in a same way as SGF. Second is when later arriving processor not smaller than the running processor. So this is the case where you have to think in your mind for this. Preemptive priority behave as non-preemptive. So when preemptive priority behave as non-preemptive, this is also same when all processes arrive together or when later arriving processes have a low priority. These are the same thing. A round robin behavior as non-preemptive. When round robin behavior as non-preemptive, when the max burst time of all processes means burst time of means burst time we think about the burst time of all processes, then the maximum of the processes like 10, 20, 30, 40. So we take the time quantum of round robin as 40 maximum, then SRTF behave as non-preemptive. Okay, time quantum is greater than equal to maximum, like greater than 40 or 40. If I take my example that I say convo effect. Which algorithm suffer from convo effect? It can be asked which algorithm is suffer for convo effect. FCFS, mostly these ask FCFS, it comes in a option, or you have to know the LGF and LRTF. These are all the things which are from the suffer from the Convoy effect. Starvation, SGF is from the starvation, as the small burst time processes come and only these small burst time processes are executing and the big burst time are not executing. This is a starvation problem. SRTF also suffer from starvation. Priority algorithm, both type, like preemptive, non-preemptive, LRT, LGF, LRTF means except HRRN, all the algorithm are suffer from starvation. When LRTF is non-preemptive, HRRN is not that much of importance. You can skip that. When LRTF is non-preemptive, LRTF is non-preemptive when all processes behave be burst time equal to 1. So when so this is long. So you have to know the scheduling algorithm of this to know the answer. LRTF, longest remaining time first. When burst time of all processes is 0, then it's behave as non-preemptive. So yeah, if I talk about here, these two important points are there. The most important is point 8. Point 7 is not asking any questions. So, but you have to know the remember maximum of completion time minus minimum of arrival time. So this is a scheduling length. So this that much of not important, but you have to keep in mind this is important. From Gantt chart you have to tell CPU utilization. So CPU utilization, like time unit for which CPU used, like time unit for which CPU is used, like it is used for, like here is used for 1 nanosecond, like 2 nanosecond or 3 nanoseconds. Upon my total number of execution time, let it this last process is executing completely in a 15 nanoseconds. So 1 plus 2 plus 3 upon my 15, this is the CPU utilization. If we talk about the CPU idle time, so then this shaded part is the idle time, that how much time is the CPU is idle upon total number of time. Okay, number of nanoseconds the CPU is idle upon my total number of time. So this is a point. I've seen this in my notes for not from a long period of time, so that's why I don't know that these points are right here. So with input output operation for n number of processes having input output requirement p, CPU utilization 1 minus p power n. So if we talk about there is a n number of processes having input output requirement, so there are n number of processes which require input output, and with input output operation for n number of processes having input output requirement equal to p. So CPU utilization is 1 minus p processes upon my n number of processes. P means number of processes upon my n processes which need input output requirement. Threads. Now we talk about the threads, and after this the fork system. These are numerical parts come from this. So next we talk about threads. Thread is the smallest unit of process that can be. So a thread is the smallest unit of processing that can be scheduled and executed by the CPU. A process can contain multiple threads. Threads are also called lightweight process as they possess some of the properties of the processors. So if you don't know what is threads, I can tell you that when the process is created, well, so assume there is a process. So in order to execute that process, we divide the process into multiple threads for execution. As threads are lightweighted, as is written that a thread is the smallest unit of processing that can be scheduled and executed by the CPU. Okay, so that means we are executing the process, but now when the concept of threads is come, we divide this process into multiple threads in order to get the parallelism. Means parallelly we can do the task. A process can contain multiple threads. Process can contain multiple threads. Threads are called also called as lightweight processes, as they possess some of the properties of the processors. Okay, each threads belong to exactly one processes. Each thread is belonging to exactly one processes, as there is the normal thing. Uh, Threads run in parallel, improving the application performance. Okay, these threads, why process is divided into threads? In order to get the parallelism. So parallelly tasks are executed. So this is priority assigned to the threads, just like the processes. We can assign the priority to the threads also. Each thread has its own control block, TCB. Wait. Hmm. Each thread has its own thread assigned to priority. Okay. Each thread has its own thread control block TCB, just like process and context switch occur for the thread also. Okay, so all the things are same. Only the difference is that the process is divided into multiple threads in order to get the parallelism, and context switch is also present there in the threads. Okay, so what we have to know is this: what are the things shared among the threads, and what are the things which are unique for each thread? This is the questions which come in the exam. Like, what are the things which are shared among the threads is code segment, section, sorry, code section, not segment, code section, data section, OS resources, and open files and signals and heap. These are the things which are shared among the threads. It is not unique for the each and every thread. It is shared among the threads. What are things which are unique for each thread? Thread ID. As we know, ID is unique for everyone. So that means thread also ID is unique. Register set is also unique. Stack is also unique. Program counter is also unique for each thread. Okay. So there are two types of threads: single-threaded processes and multi-threaded processes. A single-threaded processes contain the execution of the instruction in a single sequence. In other words, one command is processed at a time. Okay, single-threaded here. Here, these are the terminology. There's no caution directly come from the definition. These are things which are to you have to know as a CSE person. These things is spotted, shared among the threads, and unique for the threads. Multi-threading concept is allow multiple threads to share the same some resources of a single process, allowing the execution of multiple parts of the program at the same time. Example: CPU, memory, input output devices. In browser, multiple tabs can be different threads. This is an example. Browser, multiple threads can be different threads. In MS Word, one thread to format the text, another thread to process input, etc. So with the example, single threaded processes, yeah, single thread, code data file and register stacks. And here each has its own. These are the multi-thread processes where multiple threads are there of a single process, and they are the things which are unique for every thread is stack, register, and code. Stack, register, and thread ID, register set. These are types of threads. Here you can see there are two types of threads. There are two types of threads: user level threads and kernel level threads. Okay, so there is also important thing is one important things which we discuss here, and another important things which are going to discuss is user level thread versus kernel level threads. Okay, you have to just know the meaning of these what are the difference between them, and but there's only single thing which is unique in them. You have to know that, which we discuss. User level thread, it is a type of thread that is not created using system call. Okay, user level threads are the threads which are not creating using a system call. System call, what is system call? Where we discussed earlier, that system call is held when a process or user program want a resource from the kernel, or we can say OS. So when we want any resource or anything from the computer, we a process, our yeah, means a user process make a system call, that means request from a OS to grant a resource. It is implemented by the user. User level threads are implemented by the user. The kernel has no work in the management of user level threads. Okay. Kernel level threads, it is directly handled by the OS. Kernel level threads is directly handled by the OS. It does not have any information about user level threads. Context switch is slow. In kernel level threads, context switch is comparatively slow. User level threads, multi-threading in user processes create without kernel intervention. Multi-thread. Multi-threading in kernel processes, kernel itself is multi-threaded. What is the point of saying here is user level threads, the process is divided into multiple threads, but OS does not have any knowledge that this process has multiple threads. It only execute the user level process as a normal process. But in user level process, that the process is also divided into threads, but OS doesn't don't know. Okay, but in kernel level threads, OS itself divide the process into multiple threads. Context switch is very fast in user level threads. Context switch is slow in kernel level threads. Okay, if one a thread is blocked, OS block entire process. This is an important point. If one, if because as OS doesn't know about the user level thread, okay, OS only execute the process as a normal process. It does not know that whether it is a user level thread or whether it is having multiple threads or not. It only execute the process as a normal process. But that's why if one thread is blocked, if one thread is blocked, then the entire process is blocked. Okay, that means all the threads of this processes get blocked. Individual, but in kernel level threads, at the having it's having a knowledge about their own thread which is created by the OS kernel, so individual thread can be blocked. Both of them, user level thread, kernel level thread, having a context switch. So generic and can run on any OS, and it is specific to OS. It is partition is, or it's a multiple threads are done by the kernel, so specific to OS. It is generic to OS. No need to remember this one point. Fast to create and manage, slow to create and manage. Okay, just I want to give you this point only. That's when the in user level thread, when the one thread is blocked, the entire process is blocked. And it's kernel level thread when individual threads can be blocked. System call. What is a system call? Programmatical way in which a program requests a service from a kernel. It's a programmatical way in which a computer program requests a service from a kernel. How system call works? System how system, this is a basic point. If you already know, just don't need to go through this. But if you don't know, you know want to know about system call, you can remember. But this is not that much of needed. So what is system call? If a process want a resources from a uh, OS, so it make a system call, like calling a kernel and saying that I want this resource, like this, because as a resource is a private property of a OS, so it allocate according to the authentication of that process, that it is whether it is granted or not that resource. So how it is work? Request for a process for a user space. So that means processes in request interrupt request for kernel, and the interruption is going to the kernel. Control transfer to kernel, that then the and user from the user control, then the control pass to the kernel. Kernel check if operation can be done or not. If it's authenticate person, or operation can be done, that the resources can be given. Kernel perform operation, kernel return the output to user process. Okay, this fork system call here, the basically the numerical is given, like you have given a program and fork system call, and you have to tell how many children processes are there, how many parent processes are there, like that. So fork system call is used for creating a new process which is called a child process. So from basically here the numerical is come, numerical, or we can say a programmatical uh, numerical question is come, not the theoretical come from this fork system call, with a process that make a fork system call. Parent child is starting after the fork call while it create. It takes no parameter for and return an integer value. Okay. So just you have to remember here, this is a fork system call. It is the question come from the numerical part, so no need to discuss this here. So, but if I want to know, fork system call is like it is explained through code only, not like that. But you have to remember this while solving the numerical. You have to just remember this: negative value created, creation of a process was unsuccessful. Creation of a child process was unsuccessful. Zero means return to the newly created child process. Zero return to the child process. Positive value return to the parent and caller the value of the contain programming ID, newly created child process. So from this part, a numerical is come, so not theoretical part is come. This is a formula which I have written, but it can be if a question is become more tricky, so you don't have to apply this formula, you have to do it manually. So total number of processes according to fork system call, number of fork system calls are there is in the power of n. So like there is a 5 fork calls, so 2 ki power 5, that means 32 total number of processes which are created. If a question asks how many child processes are created, so 2 ki power n minus 1, that means if the number of total number of processes are 5, then 2 ki power 5 minus 1 means 31 number of child processes. How many parent processes are created? Only one parent process is created. Weight system call, and this system call concept, from this system call concept only the numerical part is come based on the this. So from here to here, on fork system call, weighting system call, these from this only numerical part is come from, basically from the fork system call. Weighting system call, no question is directly asked, like you have to know the know how weight is work in order to solve the question. Awaits call block the calling process until one of its child process completed. Await call block the calling process until one of its child process completed. After child process terminates, parent continue its execution after wait system call instruction. That what is the meaning of wait system call? In the, like in the code, there is a fork system call and a wait method is also given. So how to tackle that? So this is a concept basically used in the synchronization, basically in the uh, this from this concept, one question is also uh, come in the PYQ. So you have to see the numerical, not the theoretical part of this from these two topics, for system call and weight system call. So what is the meaning of weight system call? I have tell you that a weight call, when the weight function, this function is called, it block the process. Like it's block the parent, like parent call is it block the parent until one of its child gets completed. After child process terminate, parent continues execution after wait system call. Okay, so that's how we completed our theoretical part. I will tell you what are the things which is important. I again want to mention that what are the things which is you have to know, like what are the preemptive algorithms, what are the non-preemptive algorithms. Then you have to know the concept of long-term scheduler, short-term scheduler, and the medium-term scheduler for theoretical part. Then you have to know the throughput throughput formula, and after that, this is important part, and CPU utilization. And this is important part. Okay, you have to remember this CPU utilization formula and CPU idle time. How to calculate this formula, and what are the things shared among threads and what are the things not shared among threads. This is important. Many PYQs come from this concept, and no PYQs come from this concept, but just you have to remember this. And from this, a numerical is came. Numerical is from this chapter. Numerical is came from two types of numerical. One is from weight system call along with the from fork system call, combining weight system call also. Like one numerical is, one code is come where the fork method and weight method is used, and you have to tell the output. And another question is from this scheduling algorithm, SGF, SRTF, RR, like this. Okay, so from this chapter, this only come. So thank you for watching this video.